Hi everyone, welcome to this GCSE Higher Revision video. There's 86 days to go into your GCSE Maths exam, and if you've done the video so far up until today, well done, keep going, you're doing fantastically well. And in today's video, we're going to focus on compound interest. So compound interest, if you've got the revision cards, revision card 56 would be a useful one for you. But in this video, we're going to look at compound interest and we're going to look at how to answer those compound interest questions. So I'm going to go through some questions, I'll give you some to do yourself, remember to press pause and to try those, and then I'll talk about the practice questions as well. So let's get started.
Hi, today we're going to be looking at compound interest. Now here's a typical compound interest question, and we're going to do this question first of all without a calculator and just using our knowledge of percentages. Then what I'm going to do is I'm going to show you a very useful formula for compound interest, and then we're going to do some typical questions using it. So here's the question. It says James invests £8,000 in the bank for 2 years. It earns compound interest of 5% per year. And what that means is that he puts money in the bank, it then goes in the bank for 1 year and he earns 5% interest in the first year. The bank then add that on, he's then got that amount of money, and then they're then going to add on another 5% in the second year. And the question says, work out the total amount of money James has in the bank at the end of the 2 years. So first of all, let's do this question using our knowledge of percentages and without a calculator. So he puts £8,000 in the bank. So let's find out how much money James has in the bank after 1 year. So let's take the £8,000, and what we're going to do is we're going to work out 5% of it. Now one approach would be to divide by 100, which is £80, and get that, and then times it by 5, which would be £400. That's one approach. Or another approach could be to get 10% and then half it to get 5%. So either one of those approaches would be fine. So what I'm going to do is I'm going to get 10%. So 10% of £8,000. So 10% of £8,000 would be equal to get 10% of something, you divide it by 10, so that'll be £800. So 10% is £800. Now to get 5%, what we're going to do is half it. So 5% of £8,000 would be half of 800, which would be 400. So that means that 5% of £8,000 is 400. Now, because the money in the bank earns 5% interest per annum, at the end of the first year, he'll have the £8,000 plus 400, which would be £8,400. So he'll have £8,400 after 1 year. So after 1 year. Okay, so that's how much money James has in the bank after 1 year. We now want to find out how much money James has in the bank after 2 years. Now, because it's compound interest, what that means is then to work out how much money he has in the bank after 2 years, the bank now work out 5% of this amount of money. So we now need to work out 5% of 8,400 and add that on. And that's how much money he'll have in the bank after 2 years. So let's find 5% of 8,200. So let's get 10% to begin with. So 10% of 8,400. Divided by 10 would be £840. Now that's 10%, we want 5%, so we're going to half that. So 5% of £8,400 would be half of that, which would be £420. So that means that in the second year, it earns £420 interest. So it gets added on to what he has in the bank account at the beginning of that second year, which is 8,400. So we're going to do 8,400 plus 420, which is equal to £8,820. So that means that in the bank account after 2 years, James will have £8,820. And that's it. Now, if the question was worded slightly differently, and rather than asking us for the total amount of money James has in the bank, and it just asked us for how much interest he earns after 2 years, the answer would be £820. That's how much interest he earns, but the question asks for the total amount of money, and that's it. So that question, we've done a compound interest question just using our knowledge of percentages, and we've just added on 5% for 1 year, then got that amount, worked out another 5%, add that on. If it said 3 years, we could then work out 5% of that and add it on and so on. Now that method could be quite time consuming, because what if the question said after 20 years? Well, we don't want to be doing this for 20 years. What we want to do is a quicker and easier way to work that out. Now, before we do that, I'm going to look at a topic called multipliers. Now, whenever you've worked out percentages before and you've worked out percentages of amount, and so we've looked at how to increase and decrease things using percentages, you may have encountered a topic called multipliers. And what I'm going to do is I'm just going to make sure that you remember those now. So here's some questions on multipliers. So we're going to increase £500 by 8%. We're going to increase 3,500 by 13%. We're going to decrease 3,000 by 2%. And we're going to decrease 8,000 by 24%. So if you know what multipliers are, you can remember what multipliers are. Try to do these questions now using your knowledge of multipliers. So feel free to press pause and then to try this question using multipliers. Otherwise, if you need a bit of a recap of multipliers, then just watch me talk about it. So the first question says increase 500 by 8%. Now, if you increase something by 8%, well, you have 100% to begin with, and then if you increase it by 8%, you would have 108%. And 108% as a decimal number would be 1.08, changing your percentage to a decimal. So if we wanted to increase 500 by 8%, we could use this multiplier. We would just take our 500 and we would just multiply it by 1.08, and that would increase it by 8% for us. So if we take 500 and we multiply by 1.08, that's equal to 540. So if you increase 500 by 8%, you get 540. And this multiplier just means that we can increase 500 by 8% really quickly and easily. Another way to do it would be to take our 500 and divide by 100, which would be equal to 5, that's 1%. We can then multiply that by 8 to get 8%, and that'd be 40, and then take our 500 and add on 40, and that's equal to 540. But using this multiplier just makes it a lot quicker and easier. So for instance, we just said, well, we have 100% to begin with, we're increasing by 8%, so we'd have 108%. So we just change that to decimal, so that's 1.08, and we just multiply this by 1.08. So for instance, if we wanted to increase 3,500 by 13%, we just take our 3,500 and we multiply by 1.13, because if you increase 100% by 13%, you'd have 113%, and then that's just 1.13. And then if you do it in your calculator and do 3,500 multiplied by 1.13, that's equal to 3,955. And it just makes it just a bit quicker and easier than working it out step by step. Now, if we look at decreasing something by a percentage, well, if you've got 100% to begin with and you decrease it by 2%, you'll be left with 98%. And 98% as a decimal is 0.98. So we would just take 3,000 and multiply it by 0.98, and then that would decrease 3,000 by 2%. So 3,000 multiplied by 0.98 is equal to 2,940. So we've decreased 3,000 by 2%. And finally, if we wanted to decrease 8,000 by 24%, we've got 8,000 to begin with. We want to decrease by 24%. So if you think about it, if we've got 100%, we take away 24%, we'll be left with 76%. So we just multiply by 0.76. And 8,000 multiplied by 0.76 is equal to 6,080. So that means if we decrease 8,000 by 24%, the answer would be 6,080, and that's it. So these multipliers are really useful whenever you're doing an increase and decreasing by a percentage, but they're really, really important whenever we're looking at compound interest. And let's have a look at that now. So we can actually use these multipliers to make our compound interest questions a bit quicker and easier. Because what we can do is, in this question, what we could have done was, we could have taken his initial amount of money, the £8,000, he put it in the bank and it earned 5% interest in the first year. So we could multiply by 1.05. And then there's another year, and then we could multiply by 1.05 again. So we could take £8,000 and multiply it by 1.05 and by 1.05 again. So that'll be 1.05 squared. So we could take 8,000 and multiply it by 1.05 and then square that on our calculator, and you get that's equal to 8,820. And that's what we got. That's equal to £8,820. And that's the same as what we done whenever we done it before. That was equal to £8,820. But it's a bit quicker and easier. And the way we can write this down is as a formula. We could write the initial multiplied by the multiplier to the power of time. And what that means is, if you want to do a compound interest question, if you take the initial amount and then multiply it by the multiplier, whatever that is, to the power of time, then that will give you your answer straight away. So for instance, in this case, the initial amount of money was £8,000. The multiplier, because it's going up by 5% each year, the multiplier will be 1.05 because it's going up by 5%. And then to the power of time, because it was invested for 2 years, it was then to the power of 2. So then we would just do 8,000 multiplied by 1.05 squared, and then that gives us our answer. So now let's just change our question slightly. So the question says, James invests £8,000 in the bank for 3 years and earns compound interest of 5% per year. Calculate the amount of money James has in the bank at the end of 3 years. So we do initial multiplied by the multiplier to the power of time. So the initial amount of money was £8,000. We're then going to multiply that by the multiplier. Now it's going up by 5% each year, so it's going to be 1.05. And then to the power of time, this time it's 3 years, so we're going to do to the power of 3. And if we type that into our calculator and we do 8,000 multiplied by 1.05 cubed, that's equal to £9,261. So the answer is £9,261, and that's it. So this formula for compound interest just makes our questions a lot quicker and easier, and it's quite a straightforward formula. So let's have a look at a question now for you to try. So this one's for you to try now. It says, Jenny invests £7,000 in the bank for 4 years. It earns compound interest of 2.5% per year. Calculate the amount of money Jenny has in the bank at the end of 4 years. So have a go at this question now. Feel free to pause the video and to try this question. Okay, so remember, it's initial multiplied by the multiplier to the power of time. So the initial amount of money is £7,000 multiplied by the multiplier. Now, it's gone up by 2.5%. So if you've got 100%, it goes up by 2.5%. You would have 102.5%, or as a multiplier, that would be 1.025. Okay, so that's the multiplier there. Now that was a bit trickier because it was a decimal number, but it'd be 1.025%. If you wrote 1.25%, that would be a 25% rather than 2.5%. So that's why the multiplier is 1.025. And then to the power of time, because it's invested for 4 years, it's going to be to the power of 4. So we now just need to do 7,000 multiplied by 1.025 to the power of 4, and we get that's equal to £7,726.69, and I've rounded that to the nearest penny, and that's it. So the answer is £7,726.69, and again I've just rounded that to the nearest penny, and that's it. So that's how much money Jenny would have in the bank after 4 years, and if you got that right, well done. Okay, so we've looked at questions whenever we put money in the bank and it's going up. Sometimes we have to deal with questions like money questions or finance questions, where actually the value of things are going down. So the value of a car decreases by 5% per year. So if you bought a car 2 years ago for £10,000, work out the value now. And remember, this is your formula. So I want you to have a go at this question now, and just remember it's going down, so think what your multiplier would be if it's decreasing by 5% each year. So feel free to press pause and try this question now. Okay, so Sophie bought the car for £10,000. That's the initial £10,000. Multiplied by the multiplier. Now it's going down by 5%, so we left with 95%, so decimal 0.95. And then to the power of time. Well, she bought the car 2 years ago, so it'll be to the power of 2, or squared. So we're going to do 10,000 multiplied by 0.95 squared, and that's equal to £9,025. So the value of the car now is £9,025, and that's it. Okay, let's have a look at one last question. And sometimes the situation isn't actually based on money. It could be where you've got perhaps the population of squirrels on an island in 2010 was 4,000, and each year the population increased by 18%. In which year did the population first exceed 10,000? So in this question, it's not obviously to do with money, it's about squirrels, but we can use the same formula. So we've got initial multiplied by the multiplier to the power of time. So if you want to try this question, feel free to try it now yourself, and just remember what we're trying to do is find out how many years it takes for the population to go from 4,000 to above 10,000. So feel free to try the question now yourself. Okay, so in this question, we've got initial. Well, the initial amount of squirrels is 4,000, so 4,000. Multiplied by the multiplier. Now, it's increasing by 18%, so that would go up to 118%, so the multiplier would be 1.18. And then to the power of time. I'm just going to put t there, because in this question, we're not told how many years it is. We're going to have to work out how many years it will take to get an answer that just exceeds 10,000. So we're going to try different values for t until we get an answer that's just above 10,000. So let's do that. So let's start off with 4,000. Multiplied by 1.18, and I'm going to try maybe 3 years to begin with and see what happens after 3 years. So 4,000 multiplied by 1.18 cubed, and that's equal to 6,572.128 squirrels. Okay, so as you can see here, the number of squirrels hasn't exceeded 10,000. Now, so that means we need to try a bigger value for t. So I'm going to try this time, I'm going to choose 5. So I'm going to do 4,000 multiplied by 1.18 to the power of 5 and see what we get. So I'm going to change my power from 3 to 5 and press equals, and that gives me 9,151.031027 squirrels. So as you can see, it's not quite 10,000 yet. So now let's try the power of 6. So let's try 6 years. So 4,000 multiplied by 1.18 to the power of 6 and see what we get. So we're going to change the power from 5 to 6. And fantastic, we've got 10,798.21661 squirrels. And as you can see, the number of squirrels has now exceeded 10,000. So after 6 years, the population of squirrels would exceed 10,000. So let's work out what that would be. So 2010 was the beginning. So you've got 2011, 12, 13, 14, 15, 16. So it'll be 2016. So that's the first year where the population of squirrels exceeds 10,000. And that's it.
And that's it. So this has been the video on compound interest. So I really like this topic. So compound interest, remember, it's initial multiplied by the multiplier to the power of time, and that'll help you with these compound interest questions. I really hope you found this video useful. Again, it's one of those topics where in terms of the context, that's going to change in terms of the question. So it'll be useful to try the practice questions. So if you go to the description below, the practice questions below will give you some useful questions to practice on compound interest. Again, I really hope you found this video useful. If you have found it useful, please like it, please subscribe to the YouTube channel. And if you've got any friends who might find these videos useful, please recommend it to them as well. So thanks very much, and I'll see you tomorrow at 3 o'clock. Cheers, bye.